Welcome, dear learners, and our topic is surface active agent. So, we have taken this topic as it is very important to know what is surface active agent, what is its role in different pharmaceutical formulations, what are its types, what are its application. So, we will study each and everything step by step. So, starting with what is the definition of surface active agent. So these are the learning outcomes of this module which you will find in this video. So first one is the definition of surfactant, then second one is introduction to surface active agent, then third one is mechanism of action of surface active agent, fourth one is classification of surface active agent, fifth one is discussion of individual class of surface active agent, then HLB scale, and lastly the properties of surface active agents. So starting with definition of surface active agent or simply surfactant. What is surfactant? A surfactant is depicted schematically as a cylinder representing hydrocarbon portion with sphere representing the polar group attached at one end. So in a layman language, surfactant can be easily defined as a cylinder in which there is a hydrocarbon which consists of hydrophobic portion and a sphere which consists of hydrophilic portion or simply a polar portion attached at one end. So in a surfactant, at one end there is a hydrophobic portion and at the other end there is a hydrophilic portion. So the hydrocarbon chains are straight because rotation around carbon bond bends, coils and twists them. So due to this reason the strain or the chains of surfactant is bended, coil and twist as the rotation around the carbon bond is straight. Now what are the surface active agents? Molecules and ions that are adsorbed at interface are termed as surface active agents. So in our previous video we have mainly discussed what is interface. So in simple language we can say that interface is a phase which separates the two states of matter, say for example solid, liquid or solid gas. So the phase separating between the two states of matter is simply called interface. So the molecules and ions that are adsorbed at the interface are simply termed as surface active agents or surfactant or amphiphile. Now the molecules are ion which have certain affinity for both polar and non-polar solvents. So these molecules which are surfactant have the affinity for polar as well as non-polar solvents, and depending on the number and nature of the polar and non-polar groups present, the amphiphile may be hydrophilic, lipophilic or may be reasonably well balanced between these two extremes. And so depending upon the nature of surface active agents which can be polar or then non-polar, so it can be a hydrophilic. Whenever it is polar, so it is hydrophilic, and whenever it is non-polar it is simply termed as lipophilic, or sometimes it may be a combination of hydrophilic as well as lipophilic compound. So due to the amphiphilic nature of surfactant which causes them to adsorb at interface, whether they may be liquid or in gas or liquid. So as I have already discussed that in the interface the state of matter may be same or it may be different. So the amphiphilic nature of surfactant mainly depends upon the rate at which it is adsorbed at the interface. Now this is the general structure of surfactant. So hydrophilic head, which is simply denoted by the red color ball like structure, and the hydrophobic tail which is determined. So here you can easily see that surfactant consists of monomer which is made up of head, and the polar part is the hydrophilic and the tail is the non-polar part and it is called hydrophobic. So from the definition it is clearly stated that surfactant is a combination of hydrophilic and hydrophobic, and in that hydrophobic is head, hydrophobic is tail and hydrophilic is head. Now, what is the mechanism of action of surfactant? So, surfactant can work in three different ways. First one is roll-up mechanism, second one is a emulsification, and third one is a solubilization. So, first one is a roll-up mechanism. So, here the surfactant lowers the oil solution and fabric solution interfacial tension in this way that it lifts the strain of the fabric. So, what is the main motto of the surfactant? That in each and every field it has main motto of decreasing or reducing the interfacial tension. So here how it works, that in order to reduce the surface tension, it lowers the oil in water or oil in solution and fabric in solution, and by lowering the tension it lifts the stain of the fabric. So second one is the emulsification. The surfactant lowers the oil solution interfacial tension and makes easy emulsification of the oil. So by lowering the interfacial tension of oil in the solution, it causes the emulsification of the oil in a better as well as easy way. And third one is the solubilization. Through interaction with the micelles of a surfactant in a solvent, a substance spontaneously dissolved to form a stable and clear solution. So what do you mean by micelles or micelles? Simply, at critical micelle concentration, or the concentration at which the micelles formation takes place, is called critical micelle concentration, or simply a CMC. So it is a group of surfactant which act together in order to reduce the interfacial tension, and by this they spontaneously dissolve and form a stable and clear solution. So this is one of the second advantage of the surfactant, that apart from lowering the interfacial tension, it also increases the solubility. So in these three ways how the surfactant acts, it can be clearly understood. So now let us move towards classification of surfactant. It can be classified on the basis of charge groups present in their head. And non-ionic surfactant do not have any charge group over its head, as simply we can consider that non-ionic are non-polar, so they don't have any type of charge over its head. The head of an ionic surfactant, as the name itself suggests, that it is ionic surfactant, so it contains ions and it carries a net charge. If charge is a negative, then the surfactant is more specifically called as anionic, and if charge is positive, it is called cationic. So depending upon the charge present on the surfactant, it can be classified. So if negative charge is present, then it is anionic, and if positive charge is present, then it is cationic. If surfactant contains a head with two oppositely charged group, it is termed as deuterium. So whenever surfactant, it consists of both the charge, and that both the charge that is of oppositely charged group, that is negative as well as positive, then it is termed as deuterion. So depending upon this, it is mainly classified into the four types. First one is the anionic surfactant, second one is the cationic surfactant, third one is non-ionic surfactant, and fourth one is deuterion or the amphoteric substances. So means simply they consist of two oppositely charged in a single surfactant. So starting with anionic surfactant, so here the head is negatively charged, as the name itself suggests that it is anionic, so head is itself a negatively charged, and it is used widely for preparing shampoos due to its excellent clearing or the excellent cleaning properties and high hair conducting effects. Due to its conducting property as well as its cleaning property, it is widely used for preparing shampoos. It is also effective in oil cleaning and oil clay suspension. So here its example is SLS, sodium lauryl sulfate. So here you can clearly see that sodium is attached with the lauryl sulfate group. So here Its mechanism of action can be clearly understood that its head is negatively charged and it is attached with the sodium which is positively charged, and its application is in preparing the shampoos, and this is the chemical structure of the SLS, that is sodium lauryl sulfate. Now, most commonly used anionic surfactants are alkyl sulfate, alkyl ethoxylate sulfates, and soaps. Most of the anionic surfactants are carboxylate, sulfate, and sulfonate ions. So, in the negatively charged group, which types of surfactant or which type of functional groups are present? So, they are carboxylate, sulfate, and sulfonate ions. And most commonly which are used, they are alkyl sulfate, alkyl ethoxylate sulfate, and soap. So the straight chain is a saturated or unsaturated till C12 to C18 aliphatic group. So from the structure of surfactant you can clearly see that it does not have any aromatic group, it is simply a straight chain, and it consists of aliphatic groups, and it may be saturated or it may be unsaturated. So the water solubility potential of the surfactant is determined by the presence of double bonds. So its solubility is determined by the presence of number of double bonds into it. Now moving towards the second class of surfactant, that is cationic surfactant. In solution, the head of the cationic surfactant is positively charged. So from its name it can be clearly understood that this type of surfactant contains positively charged. They are quaternary ammonium compounds and they are mostly used for the disinfectant and preservative properties, as they have good bacterial properties. So as they are positively charged and also they have quaternary ammonium structures or the type of compound, so they are mainly used in the disinfectant, which is used to kill the microorganisms, and for the preservative property, as they have good bacterial property, bactericidal property, we can also consider that they kill the growth of bacteria. Then used on skin for cleaning wounds or burns. Most used cationic surfactant are the cetrimide, which is tetradecyl trimethyl ammonium bromide with dodecyl and the hexadecyl compounds. So here you can see the structure of alkyl quaternary system or simply the cationic surfactant systems. So this structure is of cetrimide and its IUPAC name is also mentioned here, and depending upon that it shows its property like that of disinfectant, preservative, then for burns as well as cleaning wounds, etc. Now moving towards the third type of surfactant, that is non-ionic surfactant. This surfactant, as the name suggests, they do not have any electrical charge which makes them resistant to water hardness deactivation. They are less irritant than other anionic or cationic surfactant. So this is one of their advantage, that they are less irritant when they are used. The hydrophilic part contains polyoxyethylene, polyoxypropylene or polyol derivatives. So these are the types of functional groups like the polyoxyethylene, propylene, then polyol derivatives, etc. So the hydrophobic part contains saturated or unsaturated fatty acids or fatty alcohols. So in the hydrophilic part we have seen which types of groups are present, and in the hydrophobic part it contains saturated or unsaturated fatty acids or fatty alcohol. They are excellent grease, oil removers, and emulsifiers. So they have this type of property which makes them excellent grease or oil removers, or simply they are emulsifiers. Now, non-ionic surfactant can be further classified as first polyol ester, polyoxyethylene esters, and third is the polyhexamer. Now, polyester includes glycol and the glycerol esters and sorbitol derivatives. So this is the chemical composition of the polyesters, that it mainly includes the glycol and the glycerol esters as well as sorbitan derivatives. Then polyoxyethylene esters, it includes PEG40 or PEG50 or simply polyethylene glycol. So depending upon the type of functional group and its molecular weight, it can be classified as PEG40 or PEG50. And most commonly used are ethers of fatty alcohol. So ethers of fatty alcohol are commonly used here as a functional group. Now moving towards the last category of the type of surfactant is amphoteric. These surfactants are very mild, making them particularly for use in personal care preparation over sensitive skins like dermatological properties. They can be anionic, cationic or non-ionic in solution depending upon the acidity or pH of the water. So its name suggests that they consist of both the types of charge. So they can be anionic, cationic, non-ionic, and it mainly depends upon the acidity or pH of the water. Now what are its application? They are mild first of all, and they are mainly used in various skin preparations like ointment, then liniment, lotions, etc. So they have somewhat type of skin related properties, and those surfactant may contain two charge group of different signs, and in positive charge is almost always ammonium, but the source of negative charge may vary like carboxylate, sulfonate or sulfate. So as I have mentioned that its name is amphoteric or simply a deuterion. So it consists of two charge compound like positive charge and that of negative charge. So in 99% case, in the positive charge it is always ammonium, but in case of negative charge it may vary and it may consist of functional groups like carboxylate, sulfonate or sulfate. Now this is the structure of amphoteric sulfate. You can see here betaine is used. So here at one side like that of nitrogen, it has positive charge and it mainly indicates the presence of ammonium, and it consists of carboxylate functional group which consists of negative charge. So here is the formula of alkyl betanes, where it is a type of polymer, so it has value of N, and where the number of carbon chain can go from 10 to up to 22 carbons. So this is the example of amphoteric surfactant. Now this topic is one of the important in order to know that HLB scale, that is hydrophilic-lipophilic balance. We can know depending upon this scale's reading that our surfactant is hydrophilic or it is lipophilic, etc. So this is a scale showing classification of surfactant function on the basis of HLB values of surfactant. Now higher the value of HLB, the more it is hydrophilic. Example, spans with low HLB are lipophilic. So if the value of HLB is low, then they are mainly considered as lipophilic or simply hydrophobic, and twins with higher HLB value, they are mainly called as hydrophilic. Now this is the HLB scale. You can clearly see here that most of the anti-foaming agents, they are simply lipophilic groups. So they have the HLB value from 1 to 3. Then water in oil emulsion, they have the value between 3 to 9 or simply between 3 to 7 we can consider. Then comes wetting and spreading agent, they have the HLB value between 7 to 9. Then as the value of HLB scale increases, then its hydrophilic property increases. So from the range of 9 to 15 there is a oil in water emulsion or simply oil in water emulsifying agents. Then from 14 to 16 it is of detergents, and from 17 onwards, 17 to 19, it is solubilizing agents. So depending upon the value of HLB scale, we can easily find out that what type of our compound or what type of our surfactant is. Now what are the properties of surface active agents? According to their pharmaceutical use, the surfactant can be divided into the following groups. as these all categories we have discussed in the HLB scale, and they are only their properties. First one is the wetting agent, then second one is a solubilizing agent, then emulsifying agent, then fourth comes dispersion, then comes suspending and deflocculating agents, then fifth one is foaming and anti-foaming agents, and sixth one is the detergents. So depending upon their functional groups or which types of groups they are easily classified into the HLB scale, and from their HLB scale value we can find out that they are hydrophilic or they are hydrophobic. Now there are some of the methods by which we can determine the HLB value. For example, first one is the polyhydric alcohol fatty acid esters. Example is glycerol monostearate. So for this we can find out the HLB value by this formula. HLB is equal to 20 into 1 minus S by A. So here S indicates saponification number of the ester, or it simply indicates saponification value, and A indicates the acid number of fatty acid, or simply the acid value. So if we are knowing the saponification number as well as acid number, and then by putting that value in this equation we can easily find out the HLB value. Now the surfactants which are having no saponification number or no saponification value, example is Bevax as well as lanolin. So for them there is another formula, and HLB is equal to E plus P divided by phi. Then E is the percentage by weight of ethylene oxide. So here we have to find out the ethylene oxide, and that surfactant, it consists of the functional group as ethylene oxide, and P is the percentage by weight of polyhydric alcohol group in the molecule. So it consists of the ethylene oxide as well as polyhydric alcohol, and the surfactants with hydrophilic portion with only oxyethylene groups. So now here is the equation is for only that type of surfactant which consists of hydrophilic portion. They don't have any type of hydrophobic molecules, and they consist of only ethylene oxide or simply the oxyethylene groups. So for them the value of HLB can be found out by E, that is percentage by weight of oxyethylene groups divided by phi. So by this method we can easily find out the HLB value. Now this is the end of our today's lecture, and still this unit is incomplete. So our next video will be on wetting agent, spreading coefficient and micellization. So stay tuned.